Hello, lovely student. It's so good to be with you today once again. Recall that in our last class we look at polygon and then the various types of polygon, the regular and the irregular polygon. So we look at the sum of angles in a given convex polygon and the sum of exterior angles as well. So we look at the various formulas in polygon that you need to arm yourself with to be able to solve problems in polygon. Then we extended our knowledge to solving real life problems, such as the case of hexagonal canvas. And please make sure you go over the video I sent to you over and over again to be able to understand everything. Today we'll look at trigonometry 1. And under this, we'll be looking at basic trigonometric ratios. So as time goes on, I will be referring to trigonometric ratio as T ratios. So we are actually considering these ratios, T ratios, with respect to right angle triangle. So without much ado, let's begin. So we will be looking at how we can derive the T ratios of sine, cosine, and tangent with respect to right angle triangle, and then apply this to solve triangle problems. So remember to equip yourself with your calculator and copy your table for this class. Okay, so let's begin. The first thing is that I want you to understand and recall the SOHCAHTOA. I know you are familiar with these mnemonics from your JS class. So looking at the right angle triangle in the three cases on the screen, the first thing that I want you to understand is that the longest side is the hypotenuse, and to recognize the adjacent side is the side opposite. Sorry, to recognize the opposite side is the side opposite the included angle, as you can see on the screen. So the other side is actually the adjacent side. So it's SOH, which we pronounce so. That mnemonic stands for opposite over hypotenuse. And the CAH, which is CAH, stands for adjacent over hypotenuse. And then the TOA stands for opposite over adjacent. The sine is sine ratio with respect to the right angle triangle. The CAH is cosine ratio with respect to the right angle triangle. And the TOA is the tan ratio with respect to the right angle triangle. So take notes on how you can identify the opposite side. And you always know that in right angle triangle, the longest side is the hypotenuse side. Okay, so once again, let's look at this SOHCAHTOA in a simplified term. We know now the adjacent, the opposite, and then the hypotenuse. Remember, the right angle triangle, this small box here stands for 90 degrees. The other two sides here and here should be what? 90 degrees, because the sum of angle in a triangle must be 180 degrees. So if here is theta, automatically this side here is 90 minus theta. Now I want you to pay attention to this 90 minus theta because we'll be making use of it later in this course. So in using alphabet A, B, C to represent the sides. Remember, C is the opposite side, A is the adjacent side, and B is the hypotenuse side. Okay, so let's go. How do we define the ratio? Number one, the sine of the angle theta is the ratio of the opposite side to the hypotenuse side of the triangle. Here, we are making use of the included side theta, included angle theta. So opposite over hypotenuse, sine theta is C over B, and this stands for the mnemonic so. Cosine of the angle theta is the ratio of the adjacent side to the hypotenuse side of the triangle. And that is to say, A is the hypotenuse, the adjacent, over B, the hypotenuse. So cos theta is A over B, which we say is R. And then the tangent of the angle theta is the ratio of the opposite side to the adjacent side of the triangle. So on the opposite over adjacent, that is C over A, is tan theta, and we represent it using the mnemonic TOA. So, and I want you to understand, and I want you to do this for me. Divide sine theta by cos theta, that is C over B, divided by A over B. When you carry out, you discover that your answer is equal to C over A, which is actually tan theta. This should show you that tan theta is the same as sin theta over cos theta. Don't ever forget that. Tan theta is equal to sin theta over cos theta. Okay, so we are going to see how we can find the side of triangle with these two values. Meanwhile, I want you to look at this triangle once again. Look at this triangle keenly. Now, I want you to pay attention to this included angle 90 minus theta. If we are considering this side, sorry, just give me a few minutes, let me do something. If we consider this side, and then A becomes the opposite and C adjacent and B hypotenuse. If we consider theta here, C becomes the opposite, A becomes the adjacent, and B remains the hypotenuse. Take note of that. So, with this, I want you to look at the screen keenly. If we consider this side, I want to show you something very important. Something very, very important. Okay, now, we want to consider this side. This side. So, cos 90 minus theta, which is this, cos 90 minus theta, is what? Adjacent over hypotenuse. If we consider this side, here is now the adjacent side. This is the adjacent side. The adjacent side. Sorry, trying to write the adjacent. And this becomes the opposite side. Take note of that. Now, so cos 90 minus theta is equal to what? Adjacent over hypotenuse, that's C over B. Now, if we consider this side, theta, included angle theta, here becomes the opposite. Here becomes the opposite. And here becomes the adjacent side. Take note of this important thing. Here becomes the opposite if you are considering this. So we talk about sin theta. Sin theta will be C over B, which you can see at the top here. Sin theta is equal to C over B. And cos 90 minus theta is also equal to C over B. It therefore means that cos 90 minus theta is equals to sin theta. This is what we refer to as supplementary angles. Supplementary angles. This is the relationship between cosine and sine with respect to right angle triangle. I don't want you to forget this. I don't want you to forget this. So, in NS, sin theta is equals to cos 90 minus theta. You can also say cos theta is equals to sin 90 minus theta. Check with your calculator. This is the reason why you will see that sin 30 is equal to cos 60. Because sin 30 is equal to cos 90 minus 30, which is 60. And you also see that sin 45 is equal to cos 45. Take note of that. And that means sin 15 will be equal to cos 75 degree. So let's use this relation to solve the problem in the next slide. First of all, I want to show you what to do here. The question wanted to find side. The question wanted to find this angle, MNL, this side. Now, all you need to do here is to use this 70 degree and 7 to find LK, find this side. This side. That is opposite over hypotenuse. So you are going to use so to get what? LK. And then to get this angle, you are going to say sine theta, you can represent it as theta, whatever, is equals to see what? Opposite over hypotenuse. That is LK over 21. So what I say is actually in the next slide. It's a hint. So I want you to look at that and solve this problem. Hint in the next. So you have the problem here. The first thing you need to do is use so to find side LK, like I say. Then use so to find angle MNL. Remember, when you do that, you get the answer. So let's look at the second case, where we need to apply the relationship between sine theta and cos theta with respect to right angle triangle. In this question, example 2, if sine 2 theta is equals to cos 3 plus theta, find the value of, if sine 2 phi is equals to cos 3 plus phi, find the value of phi. In this case, the symbol there is a Greek letter known as phi. We call it what? Phi. We call it what? Phi. So it's different from theta. Now, let's go. First thing, question. Sine 2 phi is equals to cos 3 plus phi. We need to find the value of phi. Now, let us go back and look at the relationship between sine theta and cos theta with respect to rectangle triangle. So we know that sine theta is equals to cos 90 minus theta. So what you need to do here is to substitute 2 phi for theta in this given formula. Did you see that? Now let me show you. Don't worry, this is made so simple. Look at this. Since this theta here is equals to cos 90 minus theta, replace this theta with what? This 2 phi. If you replace theta with this 2 phi, then here becomes what? 90 minus 2 phi, which is sine 2 phi is equal to cos 90 minus 2 phi. Okay, so let's move on. That means, look at this. Look at this. This implies that sine 2 phi is equal to cos 90 minus 2 phi. Can we go to the question? The question says sine 2 phi is equals to cos 3 plus phi. And we have established that sine 2 phi is equals to cos 90 minus 2 phi. It therefore means that we can equate these two equations. By removing sine 2 phi and equate cos 3 plus phi equal to cos 90 minus 2 phi, which is what you have in this line. Here, the next thing to do is to cancel out the cos, and then we have an equation where we can collect like terms to find the value of phi. When you do that, you're going to have 90 minus 2 phi is equal to 3 plus phi. Please collect like terms. By taking minus 2 phi to come and meet phi, you have 5 plus 2 phi, which is 3 phi. And take 3 to this side, 90 minus 3. So you have this, and then when you add 5 plus 2 phi, you have 3 phi. Please divide both sides by 3. When you do that, the value of phi is 29 degree. Remember to play this video over and over again and ensure that you master everything here. Okay, now let's move on to a somewhat real-life problem here. A boy walks 1,360 meters on a bearing of 120 degrees. How far south is he from the starting point? I'm going to give you the hint for this problem, and I expect you to use your calculator and complete it. The answer to this is actually 630 meters. Take note. Let's move to the next slide where I show you the hint of this problem. First thing you need to do is to draw the bearing, which you can see. 120 degrees comes down. We always draw bearing from the north, starting from the north pole, north axis, and move in clockwise direction up to 120. Then we draw this line, which is the distance moved in 1,260 meters. Where is the southern part is this line down here, which we represent as H. Then if you complete this movement, you should have, to this point, you have angle on a straight line. So to get the rest of this side is 180 minus 120, which is 60 degrees. So you now have right angle triangle, where you can say car adjacent over hypotenuse to get the value of H, which is the distance of the ball southward. So here is it. Here is the problem. The hint is let this distance due south be H, and use car to calculate H. Use car, that is adjacent over hypotenuse, to calculate H. How you arrive at 60 is what? 180 minus 150 is 60 degrees. And when you do that, your answer will be 630 meters. Now, this is a little work I want you to do on your own. Lay your hand on it, practice this class work, and then you will be amazed how you will learn this in a very simple format. So here the question says, find to the nearest degree the angle that the ladder makes with the wall, and correct to 1 decimal places the height above the ground at which the upper end of the ladder touches the wall. So very, very important. You just draw a right angle. The hypotenuse side is 20 meters, and then the distance of the foot of the meter from the wall is 9 meters. That is the adjacent side is 9 meters. And then you fix your theta as unknown. Then you use an adjacent over hypotenuse curve to find that theta. At the end of the day, you take cos inverse. That is for question A. Then you can use the same value to calculate the height of the ladder above the ground. So let's trigonometric ratio of special angles: 30 degree, 45 degree, and 60 degree. So as you can see on the screen, that is how you form the triangle. They actually form a unit circle where we obtain this. So this is actually, this particular one here is a cutout of isosceles triangle. And then here we have right angle triangle that is isosceles in nature. All you need to do is to find sine 30, sine cos 30, tan 30, as well as sine 60, cos 60, tan 60. And then when you do that, these are the ratios you are going to find. So let me show you this in the next slide, how to get it. Okay. So let me show you that this is actually a cutout of right equilateral triangle. This is, if you complete this, you will have an equilateral triangle like this. So we have here to be 60 degree as well. This place is 60 degree. That is, and this place is also 60 degree. So here is 60 degree actually. And here is also 60 degrees. So this line bisects. So here you have 30. If you have 2 here, you need 2. And then this line from here to here. Sorry, let me erase this. That is from here to here is actually 2 units. It's 2 units. 2 units. So if this line bisects the triangle, so here is 1. So you need to use Pythagoras theorem to get this vertical line here, this vertical line, which is 3, this vertical line, by saying the square of the hypotenuse plus the square of the hypotenuse is equal to the square of the opposite plus the square of the adjacent side here. So the hypotenuse is 2. You have 4 is equals to this opposite 4 plus 4 is equals to this opposite side plus what? 1. So when you collect like tens, you find you simply 4 square minus 1 square under root, you will get root 3. This is how we arrive at root 3. But here, for you to get the hypotenuse side, it's 1 square plus 1 square under root. 1 plus 1 is 1, and the square root of 2. 1 plus 1 is 2, and the square root of, we take the square root of 2 to get the hypotenuse side like this. Thus, with this, you can now find the T ratio of 30, the T ratio of 60, and the T ratio of 45, which you can see on the table. So, sine 30 here becomes the opposite of our hypotenuse, which is 1/2. And cos 30 is also adjacent of hypotenuse, which is 2/3, as you can see. And tan 30 is opposite over adjacent, which is 1/3, as you can see on the table. The same thing goes for sine 45, cos 45, tan 45, with respect to this triangle here, unit triangle. And the same thing, you look at sine 60, cos 60, and tan 60, using this. Sine 60, root 3 side, the root 3 becomes the opposite side, 1 unit becomes the adjacent side. So that's how you get this T ratio. Now, the issue now is, am I supposed to cram all this? There's actually a way you can remember this stuff. So I'm going to show you a video on how you can remember this very briefly. So just stay put for the video. Stay put and I'll play the video for you right now. Let the video appear.
Hello friend, this is Sunny Sharma over here and I'm back again with another great tutorial of how to memorize trigonometric values within few seconds. There are many ways of remembering the values of sine, cos and other trigonometric values corresponding to 0, 30, 45, 60 and 90. But believe me, I find this one to be the easiest one, as practically you don't have to write anything down, you just need your hand to remember all those values. Not even for sine and cos, but for all the trigonometric values. So without any further ado, let's begin. To start off with, take your left hand with palm facing your face. Now here, the little finger represents 0 degree, the ring finger represents 30 degree, the middle finger represents 45 degree, the index finger represents 60 degree, and the thumb represents 90 degree. So let's start with finding sine values. The memory trick is we always sign below. Whether it's a check or whether it's any document, we always sign below. Here what it means is we need to count the number of fingers below, take the square root of that and divide it by 2. Let's say we need to find sine of 0. So as per our rule, we need to find number of fingers below 0. Now below little finger we don't have any fingers, so the number of fingers is 0 and square root of 0 is 0 and 0 upon 2 will give you 0, so sine 0 is 0. Let's find sine 30. Now if you see below ring finger you have only one finger, so square root of 1 will give you 1 and 1 upon 2 will give you half. So sine 30 is half. Let's find sine 45. Now below middle fingers there are 2 fingers, so as per a formula sine 45 will be square root of 2 upon 2. So if you rationalize that, that is if you multiply and divide by square root of 2, you will get 1 upon square root of 2. So sine 45 is 1 upon root 2. Let's find sine 60. Now if you see below index fingers there are 3 fingers, so as per our formula sine 60 will be root 3 upon 2. Let's find sine 90. Below thumb you will see there are 4 fingers, so as per our formula square root of 4 upon 2 will give you 2 upon 2, which happens to be 1. So sine 90 is 1. So sine 0 is 0, sine 30 is half, sine 45 is 1 upon root 2, sine 60 is root 3 upon 2 and sine 90 is 1. Likewise for cos, the only difference is we are going to count the number of fingers above instead of counting it below. So let's say if you want to find cos of 0, then what we do is we count the number of fingers above the little finger. So square root of 4 upon 2 will give you 2 upon 2, which is 1. So cos 0 is 1. Now let's find cos of 30. Now you can see that above ring finger there are 3 fingers. So according to our formula, cos 30 will be root of 3 upon 2. Now let's find out cos 45. So above middle finger there are 2 fingers. So as per our formula, cos 45 will be root 2 upon 2, and if we rationalize it, we'll get 1 upon root 2. Let's find cos 60. Now above index finger there is only 1 finger. So as per our formula, cos 60 will be root of 1 upon 2. That will give us half. Now let's find out cos 90. Now above thumb there are no fingers. So cos of 90 will be root of 0 upon 2. Now root of 0 is 0 and 0 upon 2 is 0. So cos of 90 is 0. Now for tan, we just flip our hand. Observe, the little finger is 0, ring finger is 30, middle finger is 45, index finger is 60, and thumb is 90, same as the previous one. We have just flipped it. Now the formula to find tan is very simple. It's square root of the fingers above upon square root of the fingers below. Remember, square root of the fingers above upon square root of the fingers below. Now let's find tan of 0. Now as per our formula, we need to find number of fingers above little finger and also below little finger. So above little finger you can see there are no fingers, so number of fingers will be 0, and below little finger there are 4 fingers, so number of fingers is 4. So root of 0 upon root of 4 will give you 0. So tan of 0 is 0. Now let's find tan of 30. So as per the formula, we need to count number of fingers above ring finger and below ring finger. So above ring finger we have 1 finger, and below ring finger we have 3 fingers. So root of 1 upon root of 3 will give you 1 upon root 3. So tan 30 is 1 upon root 3. Now let's find tan of 45. Now you can see above middle finger we have 2 fingers, and below middle finger we have 2 fingers. So we'll get root of 2 upon root of 2, which is 1. Now let's find tan 60. So you can see above index finger we have 3 fingers, and below we have 1 finger. So tan of 60 will be root of 3 upon root of 1, which will give us root 3. So tan of 60 is root 3. Now let's find tan of 90. Now you can see above thumb there are 4 fingers, and below there are no fingers. So root of 4 upon root of 0, that will give us 2 upon 0. But you all know that if in the denominator we have 0, then that fraction is not defined. So
thank you very much.
tan of 90 comes out to be not defined.
Thank you very much for your patience and your keen observation of this interesting lesson. So you see how you can recall the T ratio of this special angle. So you don't need to cram anything. You just need to remember your hands. Please practice this over and over again. You will be so amazed how you will master the whole of this. So now let me return you to our slide so that we can solve very few problems with this T ratio before we call it a day for this interesting lesson on trigonometry 1, which has to do with what? T ratio of angles with respect to triangle. Let's move on to our slide now. So now that we've seen that, let's see how we can apply this one or two problem before we go. Okay, I'm going to tell you what to do with this problem and how you can get the value of x and y. First of all, you need to obtain the value of x before you get the value of y. And then when you look at these two triangles here, I'm going to tell you what to do. So pay attention to this. I'll just tell you what to do, and then you go ahead and get these values. Remember, you are not expected to use calculator. Start with triangle ADC, which is 60, and then we need to get the value of x, which is what? The opposite side. So we have a value here of 3 centimeters. So opposite over adjacent is what ratio? Opposite over adjacent. What ratio is that? Correct. It is what? TOA, that is tan 60, is x over root 3. So what is tan 60 that you just derive the T ratio for tan 60? Think about that. So you simply substitute that. Do not use calculator here. Do not use calculator. So you will agree with me that tan 60 is simply root 3. So you just cross multiply and then you get the answer, the value for x. Then when you get the value for x, you come and use this side. You come and use this side to calculate to get y. Here, 45. So right now we need y and we've gotten x. So still, this is x is the opposite side to this triangle, ABD. So you say opposite over hypotenuse is actually so. That mnemonic so, that is the sign ratio. So sine 45 is equals to x over y. And there you release the value for sine 45, which is 1 over root 2. You cross multiply to get the value of y. Do not use calculator to solve this problem. Lay your hand on this, and do this practice. You will be amazed how you will grab the whole thing. Okay. So this is one way to apply that. So let us look at some real life problem here now. The area of a right triangle is 50. One of each angle is 45 degrees. Find the length of the sides and hypotenuse of the triangle. So let's solve this problem. Solution. The triangle is right angle and the size of one of each angle is 45. The third angle has a size of 45 and therefore the triangle is right and isosceles. So we want to know the hypotenuse side. Already we now know that it is an isosceles right angle triangle. Let x be the length of one of the sides and h be the length of the hypotenuse. The area of a triangle is 1 over 2 base times height. But in this case, the two sides are equal. The opposite side is the height, the adjacent side is the base. Since it is isosceles, the opposite and the adjacent are equal. So if you say let x be the length of one of the sides, then the adjacent side is also x. So 1 over 2 x times x is equal to 50, which is the area of the triangle. So here we need to find the value of x. When you solve for x, you cross multiply. So x squared is equal to 2 times 50, then you find the square root. So x is 10. And that means the opposite side is 10 and the adjacent side is 10. To find the hypotenuse, you simply apply Pythagoras theorem, which is 10 squared plus 10 squared under root. Now use the Pythagoras to find h. So this is there. And when you do that, you discover that h is 10 root 2. That is 10 squared is 100. 10 squared is 100. So 100 plus 100 is 200. So you now take the square root of 200. You solve. 200 is equal to 2 root 2. Root 200 is equal to root 2 times root 100. The square root of root 100 is 10. That's why you have h to be 10 is 2. Let's move on to this particular problem. So I'm going to show you how to solve this problem. Listen carefully. If tan theta is equals to 8 over 15, evaluate sin theta plus cos theta over what? Cos theta into 1 minus cos theta. First thing, this is T ratio. What is tan? Tan is TOA. That is opposite over adjacent. So we are going to draw a right angle triangle, fix our theta, then fix the opposite side and fix the hypotenuse side. Use Pythagorean theorem to find the hypotenuse side. Then we now find sin theta, find cos theta. Then we come to this structure and substitute their value and then solve as a fraction. Let's see the hint in the next slide. Sorry. Want to see the hint for that in the next slide. So permit me to please give me a few minutes to rearrange the slide for you. Okay, so Like I said earlier, we are going to draw a right angle triangle and fix the opposite side as well as the adjacent side, and then use the Pythagoras theorem to get the hypotenuse side. Then we will now look for sin theta and look for cos theta, and then come and substitute the value here. Sin theta plus cos theta over cos theta into 1 minus cos theta. Then we solve as a fraction to get our final answer. So here is the hint. Draw a right angle triangle using TOA. Fix 8 on the opposite side and 15 on the adjacent side, as you can see right here. So we fix theta here, and then we fix 8 on the opposite side and 15 on the adjacent side. Next, we use Pythagoras to calculate the hypotenuse side. Then use SO and CA to obtain their ratio respectively. Then substitute their value and evaluate as a fraction. Please, I want you to lay your hand on this and try it, and then report to me in Mass Quora. Whatever is your challenge, we will fix this together. I just want you to do something by yourself. Having been given some hints, you should be able to think through and do it. Be responsible, be disciplined. Remember, maths require a whole lot of practice. In the same way, the last problem here, I'll also give you a hint, and then I'll tell you what to do. Make sure you lay your hand to do this thing. You'll be amazed how much you will learn in this course. Okay, now we have this problem. A regular hexagon has size of length 8 centimeters. That means all the sides, a regular hexagon has all the sides equal. Find the perpendicular distance between two opposite sides. Oh, you can see the hint here already. You can see everything here already. You can see how just to pick one side. The side is 8 centimeters. So they say perpendicular distance between two opposite sides. So this is the perpendicular distance between two opposite sides. This is it. This is a side which is opposite to this side. This is it, like this. So I decided to pick this one. Since the regular hexagon, they are all equal. All this triangle you can see here, they are equal because it's a regular hexagon. All the sides are 8 centimeters. So this perpendicular distance actually bisects any of the triangle, bisect this triangle. That's why here is 4 and here is 4. And remember, a regular hexagon, if you draw the angle in this one, a regular hexagon, each of the interior angles are equal. For a regular hexagon, interior angle like this, equal to this interior angle, equal to this interior angle, like that. All the interior angles are equal. All the interior angles are equal. And when you calculate this, each of the interior angle is 160 degrees. 160 degrees. So extending this line, which you can see here, sorry, each of the interior angle is 120 degrees, not 160. 120 degrees. You can calculate it and you can check the interior, the sum of the interior angle of a regular hexagon. Regular hexagon has 6 sides. When you calculate it using n minus 2 times 180, you will get n is 6 minus 4 times 180. When you do that, divide it by 6, you will see that each interior angle is 120 degrees. Now, look at this. The whole of this side is 120 degrees, right? Good. So that means this line here bisects the angle. Here is 60, here is 60. Automatically, if you complete this side like this, this is the right angle. Sorry, this is the angle in a straight line. So the rest will go 60 degrees, which is the interior angle. So why are we doing this? We need to get what we can use to calculate the height of this triangle, which is opposite to this 60 degrees. Here is opposite to this 60 degrees. And then we have the adjacent here, the adjacent side here to be 4 already. It's already 4. So we are going to use opposite over adjacent. That is tan 60 is equals to this side over what? 4, which is the adjacent side. But when you cross multiply, this height here is simply equal to times 60 times 4 when you cross multiply. So when you get this height, multiply it by 2. That is the distance between here to here is also equal to here to here. So when you calculate this, multiply it by 2. That is your answer for the length of the perpendicular distance between two opposite sides. Replay this over and over again and grab what I said. Do the calculation, report your challenges or your answer to Maths Forum. And when you do this on your own, you will be amazed how you will grab the whole of this lesson. Okay, so that is this is where we will stop for today on Trigonometry 1, which is actually the T ratio with respect to right angle triangle. Here is a simple classwork for you to do. Lay your hand on this and then try it, which is actually similar to the problem that I directed you to do by yourself. That this program, problem 3, and then I gave you a hint on what to do here. When you follow the same thing here, that's what you use to tackle this classwork problem. So you fix x and draw a right angle triangle, fix x, and then fix 3 on the opposite side and 4 on the adjacent side, and then calculate the hypotenuse side, which in this case you will have 5. Find cos x, find sin x, and then substitute their value here and evaluate as a fraction. So we have looked at the T ratio with respect to right angle triangle, the SOHCAHTOA, and then the T ratio of special angle. We also seen how you can recall the T ratio of special angle without you drawing the diagram or trying to cram them. Replay this video over and over again, watch it over and over again, and you'll be amazed. You can pause it and take your jottings, and you'll be amazed at what you will learn. The notes is already available. You know where to find the notes already. Thank you very much for your time and patience, and see you in the next class for Trigonometry 2, which has to do with what? Application of what? T ratio. Real-life application involving angle of elevation and depression, as well as bearing and distance. Thank you. Thank you. Thank you. Make sure you enjoy the rest of the day. Share this video with your friends, and then make sure you subscribe to my channel on YouTube, because there are so many simplified videos that you wouldn't want to miss. Also, remember to click the bell and after you subscribe so you don't miss any of my subsequent videos. Thank you very much for your time, and remain blessed.